Welcome back to another Explainer. Today, we're stepping into a slightly retro-futurist vision of our world to look at what we're calling the mirror in the machine. We're going to cut right through the noise, the hype, and all that anxiety surrounding artificial intelligence. Instead, we'll be leaning on hard, empirical data from 2026 to unpack a series of genuinely fascinating paradoxes. What you'll see is that AI is absolutely not this infallible human replacement. Actually, it's just a reflection of our own human leadership.
Okay, let's jump right in. For a long time now, the dominant narrative has basically been, AI is coming for your job. But the reality on the ground is so much more practical than that. Think of AI not as a replacement, but as a cognitive forklift. Just like the physical forklift stopped warehouse workers from throwing out their backs lifting heavy crates, AI is specifically built to lift the heavy, repetitive mental paperwork that just clutters up our daily lives.
So officially, this cognitive forklift is the systematic offloading of routine cognitive tasks to automated systems. The goal isn't to empty the warehouse of human workers, right? It's to allow human labor to scale up to higher-order complexities. This shift fundamentally elevates our baseline capability. Basically, we let the machine do the heavy lifting so we can step back and focus on the architecture. Here is the roadmap for our explainer today. We'll be covering 5 key paradoxes: the cognitive forklift, solving Bloom's 2 sigma, the Jevons paradox, decentralized data sovereignty, and finally, the thermodynamic wall. Starting with Section 1, the cognitive forklift, elevating human potential. To really understand how this forklift elevates us, we've got concrete telemetry data pulled straight from enterprise deployments in 2026. This isn't just theory, it is highly measurable. Get this. 6.4 is the median number of hours saved per week by knowledge workers who are actively using AI agents. Think about that. We're essentially handing people nearly a full workday back every single week to dedicate to much more meaningful stuff. So what are folks actually doing with that retrieved time? When you look at the heaviest users of these autonomous agents, they aren't just slacking off. They're deploying them for heavily cognitive tasks. 36% of the time, they're using them for productivity and workflow, like document editing. 21% of the time, it's for learning and research. People are essentially using AI as their own hyper-personalized research assistant. And the unit economics here are, well, they're kind of mind-blowing. When you break down the cost per task for something like software engineering, it gets real clear real fast. A routine code review that traditionally cost $48 in senior engineer time, that now costs just 72 cents using an AI agent. That is literally a 66 times cost reduction. Organizations are tracking this using the composite agent value formula, which factors in the minor human oversight needed to verify the work. The ROI is just undeniable. But it's not all just saving money on corporate spreadsheets. These cognitive forklifts are actively accelerating world-changing discoveries. Take AlphaFold 3 in computational biology. This AI has been able to identify entirely novel drug targets for cancer, and it's doing it with a 70% reduction in screening time. It's modeling the incredibly complex interactions of life-saving molecules in minutes instead of months. It's a total game changer. Moving right along to Section 2, solving Bloom's 2 sigma, the education paradox. Now, as we automate all this routine work, a big question pops up. How can we scale personalized learning to every student on Earth? Well, back in 1984, educational psychologist Benjamin Bloom identified a massive dilemma. He discovered that students who received personalized, one-on-one mastery learning performed 2 full standard deviations better. They were outperforming 98% of traditionally taught peers. The paradox, of course, was that society could never ever afford to hire a human tutor for every single child. It was pedagogically perfect, but economically impossible. Fast forward over 40 years later, and AI is finally solving this exact problem. AI agents can now provide that scalable one-on-one tutoring Bloom dreamed of, enabling true individualized mastery learning. And the results? Recent studies in science education are already showing a 1.01 standard deviation improvement using these systems. By pairing this with hybrid human-AI models to keep the students motivated, we are actively raising baseline student performance up to what we used to consider elite top-tier levels. Which brings us to Section 3, the Jevons paradox, Cole versus cognition. Okay, let's address the elephant in the room. If AI makes work faster and cheaper, isn't it just going to eliminate jobs entirely? To answer that, we have to look way back to 1865, to an observation by British economist William Stanley Jevons. He noticed that as steam engines got more efficient, coal consumption didn't drop. It absolutely skyrocketed. Why? because the lower cost unlocked massive latent demand. That exact same paradox applies to our 21st century cognitive engine. Collapsing the cost of routine execution actually expands the total market for intelligence. Because it's cheaper to generate code or research, we do vastly more of it, which creates this massive new demand for human oversight, strategy, and integration.
So the crucial takeaway here is that human value is rapidly shifting from just producing boilerplate material to actually directing the strategy. We call this the mirror effect. AI is merely a probability distribution reflecting your human leadership. It is not some infallible machine. Like, say you ask an AI to generate a blueprint for a space prison, it's probably going to hallucinate some ridiculous, totally unusable layout. It requires your creative friction and human articulacy to correct it and mold it into something highly useful. You aren't drafting the baselines anymore, you're auditing them. Because of this whole dynamic, AI fluency now commands a 56% wage premium, and the World Economic Forum is projecting 78 million net new roles globally.
Section 4. Decentralized data sovereignty. Shrinking the giant.
Look, we all kind of assume AI means we have to send all our private data up to some massive corporate cloud. But right now, the most vital innovation happening is actually figuring out how to make these giant models small enough to run entirely offline. People are actively reclaiming their data sovereignty through these brilliant new frameworks. You have Bit-Distiller, which uses local quantization. That's essentially shrinking a massive file down without losing its intelligence. Then there's Petals, which acts like a peer-to-peer network to share the computing load across regular consumer GPUs. And Vane, which gives you local first search with 100% data privacy.
So how does this magic actually work offline? It's basically a three-step process. First, quantization-aware training acts like a digital zip file, physically shrinking the weight of the AI model. Second, local vector databases map your personal files directly on your own hard drive. And third, the actual AI inference, the act of thinking and generating, runs completely off-grid using your device's own chips. The result is a highly capable AI that literally never transmits a single byte of your sensitive data to the cloud.
Oh, and real quick, while we're demystifying AI, we have to touch on that whole black box doom narrative you hear so much about. Thanks to a field called mechanistic interpretability, we are physically mapping AI brains. Using tools called sparse autoencoders, researchers can essentially put an MRI on an AI. They isolate specific neural circuits and literally debug behaviors like hallucinations. We don't have to guess what the machine is thinking anymore, we can map it. This proves it's a highly interpretable tool, not some uncontrollable magic box.
Finally, Section 5. The thermodynamic wall. Physics hits the brakes.
We talk a lot about infinite digital scaling, but out in the real world, this scaling eventually smashes directly into the hard, unyielding laws of physics. Every single calculation generates heat. We've gone from standard air cooling in the 90s to sinking whole data centers into the ocean in 2018 with Project Natick to literally piping server waste heat into municipal Arctic heating systems. But now, with local pushback rising, the industry is looking off-world entirely, toward orbital space data centers.
But here's the crazy part. You can't just launch a server into orbit and expect it to stay cold. Space is a vacuum, which makes it a near-perfect thermal insulator. According to the Stefan Boltzmann law of radiative heat transfer, a modest 1 megawatt space data center would require a massive 1,200 square meter radiator wing just to survive out there. Engineers are literally designing futuristic swarms of silver, laser-linked satellite nodes simply to dissipate the massive thermal footprint of our digital cognitive engines.
So, as we watch our data centers migrate to the bottom of the ocean and up into the stars just to cool down from the pure exertion of automated labor, we're left with the ultimate question. If the machines are increasingly handling the execution, the rote learning, and all the boilerplate tasks, the strategy belongs entirely to us. We have built the ultimate cognitive forklift. We are the mirror in the machine. So, what new frontiers will your human judgment conquer?